Okay, I thought that we would end this lesson by talking about volcanism on other objects in our solar system. So let's first start with the moon. So if you look at the moon, you'll notice that it has a dark part to it, and then you'll notice it has a whitish part to it. So the dark parts of the moon are called the maria, which in Italian means ocean. So when Galileo first looked at the moon, he thought that those things were oceans. So he called them maria. They're not oceans. So they are dark colored igneous rocks. And then you've got the white part of the moon, which is called the lunar highlands. And it is also made of igneous rocks. And the lunar highlands are heavily cratered. The maria, on the other hand, are not. So what is the origin of the dark areas and the white areas of the moon? So the white area represents the original crust of the moon. So it is made of igneous rocks. It's called a northsite. So that is the igneous rock that it's composed of. Now, how did you get the dark areas of the moon? Well, if you look at the moon and you look at those dark areas, you'll notice that every one of the dark areas looks like circles. And so what they think happened is that early in the formation of the moon was heavily bombarded by asteroids and meteors. And then every time one of these asteroids, a big one, would hit the moon, it would punch a hole through the crust, the white part of the moon, and into the mantle area underneath it. And the asteroid would have so much energy, it would impart that energy to the mantle and would heat it up to the point that the mantle material would ooze up to the surface and it would fill in the crater. And so it would fill in the crater with a basaltic igneous rock, and so that's why it's darker. All right, now let's go to Venus. Venus is very geologically active in that it does have a lot of volcanoes, and those volcanoes are constantly producing carbon dioxide. And then that carbon dioxide, we said, causes a greenhouse effect, which is the reason why Venus is so hot. So it also has volcanoes. It produces probably basaltic lava flows that cover the entire surface of Venus, and it is geologically active. It doesn't have plate tectonics the way that the Earth does, though, because the plates on Venus, they don't have a lot of water in them, so they're very thick and they don't melt easily, so it's very difficult for the plates to be pulled apart and pushed together and slide past each other. Okay, if we go to Mars, Mars has, it's geologically pretty dead because it's cooled off on the inside. But Mars does have some very, very large shield volcanoes. And the largest of those volcanoes is Olympus Mons. And this volcano is taller than the Himalayas. Okay, so it is a gigantic shield volcano. Why is it so big? Okay, it's over a hot spot, just like Hawaii is. So it's making a shield volcano, but there's no plate tectonics that is moving the shield volcano off of the hotspot, so that it keeps getting bigger and bigger and bigger and bigger because it continues to be over that hotspot. So it hasn't erupted in quite some time, and so it could be actually a dormant volcano. Io. So Io is a moon of Jupiter. It is the closest moon to Jupiter. It is the most volcanic object in the solar system. So it is even more volcanically active than what Venus is. Now, this is surprising because Io is about the size of our moon, which means it should be geologically dead. So what's going on inside of Io is the gravity of Jupiter is constantly pulling on Io and stretching it. And it's just like taking a credit card and bending it back and forth like this. It starts to get hot at the crease. So Io is very hot because of the gravitational tugs of Jupiter, and that's why it's so volcanically active. Okay, then you've got Pluto. Now, Pluto, again, is very unusual in that Pluto is covered in ice. So it has water ice and it has nitrogen ice that cover its surface. And it has plate tectonics. Now, it's not the kind of plate tectonics that we have on Earth. So it's a different kind of plate tectonics based on ice. So that you've got these plates composed of ice that can be pulled apart and they can be pushed together and they can slide past each other just like on Earth. But they're composed of not rock, they're composed of ice. And so we think that the heating mechanism has to do with when you change water to ice, you have to put heat into it. So if you take a chunk of ice and you put it on a stove and you turn up the heat, it changes from a solid to a liquid. Heat goes into it. So what would happen if you had water and it changes back into ice? It would have to give off heat. And so we think that what's happening on Pluto is that as the water is changing back into ice, it gives off heat, which then is driving the plate tectonics on Pluto. Now, it's not much plate tectonics, but it is a kind of plate tectonics. Pluto has volcanoes, but these volcanoes, instead of erupting lava, they're erupting ice. So they're erupting nitrogen ice and water ice out of them. Okay, so let's take a break, and when we come back, let's do a quiz.